first one together. I gave you a bit of time to start to factor. These are the regular kind of simple type of factoring that we're starting with. So we've got on the top here, numerator, 2m minus 5, can't factor that. On the denominator, if it's just a 1 in front, you know that on the x, if you're doing it, it's just m and m. So you're just looking for the two numbers that multiply to negative 15 and add to negative 2. So m minus 5, m plus 3. Okay, then you have the plus, and then you keep going. So you're going to go 3m. Again, if it's a 1 in front, then it's supposed to be the simple type where you just do multiplies to negative 30, adds to 1. So it'll be m plus 6 and m minus 5. The signs are really important. Like if you're getting the numbers but not the signs, you have to work on that, because otherwise you just keep getting it wrong, and you can see they don't cancel and stuff like that, right? So it'll be a pain with that. Okay, time. So as soon as you see the plus and the multiplication, you know that this is going to be using BEDMAS, right? So we've got still the same order of operations, which means I'm going to have to do the multiplication before I do the addition. Okay, so multiplication before the addition subtraction. I'm still going to factor. So on the top here, if it's a 1 in front, multiplies to 12, adds to 6, and I'm thinking m and a 6, m plus 2. Multiplies 12, adds to 8. This is just m plus 3. So then what you're doing is you are only looking at the multiplication part. Those guys can cancel. Remember that this is the same thing as making a whole line, right? And saying this is all numerator and this is all denominator. For this part of the question, if you can cancel anything numerator and denominator, you can simplify the fraction first. We talked about this last time where I said if you have a fraction that's 4 over 8 plus 7 over 3, you are allowed to simplify that first. Like you can just simplify that to 1/2, right? It's the same thing here. You can simplify each fraction individually. Then here, it's multiplication, so I couldn't simplify that fraction, so I leave that. But here, I'm looking and thinking of it as multiplication means this is all numerator and this is all denominator. So I'm allowed to cancel any numerator and any denominator as long as they're matching. So I need binomials to cancel with binomials, monomials with monomials. You can't cancel a monomial with a binomial. Okay, so this I'm going to do my restrictions. So step 1 is always factor. Step 2 is restrictions. You can do the restrictions at the end. You just have to be able to read it. Like don't cross it off too dark that you can't read your own writing, or do the restrictions now, right? So that's up to you. I can't tell the order you do the restrictions in, okay, but just make sure that if you cancel it, you still include that restriction. Like you're still going to have to write it. Okay, so here, if I do my restrictions now, I'm going to start to do these. Are we okay with doing these a little faster now? Right, so m cannot equal for this one, positive 5. This one, we're good, negative 3. This one, negative 6. I don't care about the order, I'll find it. Some teachers want it in order. I'm okay with just like listing them. I'll find it. Okay, 5 I already have, and the negative 3, I already have that. Do I have to go to the top? No. The only time you go to the top is if it's division, that's multiplication, so only the denominators. Okay, so the bottom of this one, denominator, denominator. Okay, good. I'm going to just circle that, tell myself to go back later and grab those later. Okay, so that's my rough work. We'll give you rough work usually on a test on the side or a separate paper. Okay, so just make sure you grab that at the end. So now I'm going to do my canceling. I'm going to use a pink here. So anything in the denominator with anything in the numerator, and also binomial with a binomial, monomial with monomial. So this binomial with that binomial, I can't cancel anything else. Nope, can't. Right, so can't force it. If it doesn't work, it doesn't work. So then we rewrite it. So we're going to go 2m minus 5, m minus 5, m plus 3. So I'm rewriting this all simplified and up together. So 3m, and that has an m plus 2 left over. And in the denominator here, I have m minus 5, and I have an m plus 3. Right, that's all that's left in the denominator. Leave it factored. We love factored form. It's beautiful, beautiful. Okay, and then we look to see about adding these two. So when I add these fractions, okay, I look here and I go, okay, this denominator and this denominator are the same, right? Don't look at the tops. M minus 5, M minus 5, M plus 3. They're actually already identically the same. Oh, too easy, right? You're like, oh, that's not enough. So then that means I can just add the tops. So you're just going to add the tops together and keep the denominator. And we're just going to add the two tops, but keep the denominator. So keep the denominator. So just like when we were doing fractions, if I had 2 over 5 plus 1 over 5, and the denominators are the same, you add the top, so 2 plus 1 over 5. Usually we would skip that step and just go 3 over 5, but that's what we were doing in our heads, right? So that's what we're doing here. So I'm going to show the step where I'm adding the two tops like that. Okay? I wouldn't recommend skipping any steps until you're really comfortable with it. Okay? I don't like a lot of skipping right now just because sometimes you lose a sign. So you're going to do this. Expand out the top. The denominators stay factored. We love that factored. So leave it in factored form. The reason why? Because those are going to be asymptotes, wholes. They're beautiful, gorgeous. We're going to use those later. I mean, not this year, but like maybe much, much later. But still, those are asymptotes or wholes. We love them like this, so leave it. Okay? And then, so leave this alone. Don't unfactor it. It's beautiful the way it is. And then here we're going to go 2m minus 5 plus 3m squared and 6m. We're not going to leave it like that because what do we have? Like terms. And also the order is just a mess, right? You should be looking at that and going, ugh, shouldn't I put that in descending or ascending order? Yes, right? You should feel like cleaning it up. So then one more time, 3m, that's a 3, 3m squared, that becomes 8m minus 5. M minus 5, m plus 3. That is a trinomial. Right, so I kind of go over here and I go, okay, well, it's only 3 and an m, and I have 5 and 1 or 1 and 5. So that'll get me 3 and 5. That works to get me 8 as long as they're both positive. But does that work with my minus 5? No. Okay, so then the only choice I have is 5, 1, but that would get me 15 and 1, so I can't factor it. There's only two choices there. Done. Right? So do try to factor the numerator. If you can, you're supposed to keep going. If you can't, then just leave it. Okay? Comma, and then let's write our restrictions. So m cannot equal 5, negative 3, and negative 6. Again, I'm letting you write it in any order. That's fine. Okay, so it should get repetitive, I hope, right? First step is factor, so this next one here. First step is factor. We're going to try to factor it. I can see right away there's a division, right? Division for me means that I'm going to have to restrict the top and the bottom. So I'm just going to highlight it just so I go, wait, what am I doing? Why did I highlight that? Okay, and then I'm going to have to do this part first. Right, order of operations, do this part first before I do the subtraction. And I'll do that after. Okay, so let's start to factor first. So factor, 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 so equals. Here we go. That has a common factor already of 2, 2. Right, so I'm going to grab that over here. And I'm going to take out the 2, so it's 2x squared minus 11xy plus 12y squared. So that'll be 2. And then again, I'm going to go 2 and 1. Right, you can do the letters. You can just leave the letters off. Some people go, ah. And then, so 6, 1, 12. So I can only do 1 here and 12 here, but that gets me 24. It's too big. So 2, 6. I can't do 2 and 6 because it's beside the 2. And the 6 can't go beside the 2. So then 3, 4. I'll try 3, 4. That's 8 and 3, 8, 9, 10, 11. Yep, if I'm adding to negative 11, they both have to be negative. You have to watch this sign. If that's plus, they have to be the same, right? To make it negative 11, so that'll be 2x, so that's both of them are negative, minus 3y, and then x minus 4y. Okay, and again, I'm doing that faster, but I want you to be comfortable with being able to factor decomp or the big X, up to you. Okay, or straight onto the brackets if you want. So grab that. You got 2x minus 3y, x minus 4y. Okay. Common factor first. Is there anything between a 9 and a 4? No, 9 and 4. But I see, look, a perfect square and a perfect square. This one just feels wrong, though. It feels a bit off because, what do you think? It just feels different than these other guys. 9y squared minus 4x squared. Difference of squares. And then why does it feel a little bit, this is 4x squared, 22, 24y squared. You notice what I did here? Yeah, what do you think? Yeah, the order's opposite, right? So this one is x squared's last, and this one has x squared first. So when you do the difference of squares, you can either fix the order now, or you can fix it later, but it's going to be backwards, right? You're going to have y's second and, x is second and y's first. Because you can see, look, x squared, then it goes to y squared. This is y squared, then x squared. So you're allowed to fix it first if you want, or fix it after, but it's going to be backwards. Okay, so do you want to fix it first or after?
First.
First? Okay, so I'm going to rewrite it. 4x squared plus 9y squared. That makes it not a difference of squares, but what I do is I factor out the negative. There you go. There's the difference of squares again. Yeah.
So for the question, it always needs to be in descending.
You want it matching. I mean, if this one was ascending, then that could be ascending. But since I saw on the top I have x squared and then the x squared second, I want them to match, because otherwise when you're canceling, they're backwards. So it doesn't have to be an ascending or just matching, right? So if this one was y squared, x squared, I would leave it. But because I saw the top, I'm like, oh, it's going to confuse me because I'm going backwards and forwards. I want them all to be in the same order, right? So then that would look, this one's got x squared, y squared. This one's x cubed, y squared. I'll do a common factor, but yeah, you kind of want them in the same order. Otherwise, you end up fixing it later. So see how I'm taking out a negative here? You have to fix it later with a negative. I'll show you what I mean, okay? But yeah, one way or the other, it's going to be backwards. You're going to be like, oh, it's kind of the same, but not the same. So here, if you do it this way, then I just common factor the negative out, and then I get that, right? So then it's in the same matching order, so it just looks better. Okay, so if I don't do that, so I'll write this down. So see that? So I wrote it that way. If I didn't do that, then what would have happened on the bottom, I'll let you copy that first. Okay. Where's squared?
Isn't that supposed to be squared?
No, these guys, it's a difference of squares, so it becomes 2x into 2x, and this is a 3y, 3y, yes. So single. Now, if you didn't do it that way, so let me show you what I mean. If you didn't do it this way, look, you would have had 3y minus 2x and 3y plus 2x, right? That's okay, but look how they don't match, but they almost match. You're like, oh, so close, but they're backwards. The 2x is positive, this 2x is negative, this is negative, that's positive. So what you would have to do is you would have to factor out a negative anyway, flip the signs, and then you could do that. And then it would flip it around.
So there's a negative in your final answer as well?
Yes, yeah. So you would still factor out the negative to make them the opposite sign, which I did here. Yeah, so the negative stays outside, just saying that you had to switch the order of it, yeah. Okay, so slow it down a little on the side. Sometimes I like it to do it on the side so I can see why I took out the negative. If you're okay factoring it after, that's okay, but sometimes I find this makes more sense. fix the order so they're matching, and then I don't have to fix it at the end. Okay? Okay, that's a tricky one, right? I'm just showing you a little bit of a trick there. Okay, then we've got multiplication, right? And then we have to switch the order. So I'm doing that so I remember to go back and do the restriction later on. So we're going to do this times, and then here. So this goes on the top. For this is two terms, but it's not difference of squares, right? Because there's no minus, and that's not a perfect square, and 3 is not a perfect square. Neither is y, and x cubed is not. So then all I can see that I can do is common factor x squared. And I'm going to have left 2x plus 3y, right? Which is not bad because, looky there. Yep.
What about like the negative 3x? Are we going to do that after? Like on that?
Oh, yeah, I'm going to do that after. Yes, yes, yes. Thank you. So negative 3x. Thank you.
I would forget that.
Yeah, I know. Totally just forgot that myself. Yep, totally just forgot myself. I'm going to put it over 1 to make it bigger. So, there you go. Put it over 1, make that bigger. Yeah, sorry, I forgot to write it right away. I forgot it, yes. Okay, so put the 3x there and put it over 1. Don't forget it. Good, good, good. Okay, so then that's this one up here, common denominator. Oh, sorry, yeah, common factor. Then here, I can see a 4, right? So I'm going to bring that over here again. I'm going to take out the 4. And I've got left x squared minus xy minus 12y squared. Right? And that's supposed to be simple now because it's a 1 in front. So it's 4. So it's x minus, if it multiplies to negative 12, adds to negative 1, it's negative 4y, and x plus 3y. Right? So then I'm going to write that down here on the bottom. Denominator minus 4y, x plus 3y. There you go. All right. So you'll notice that there's some repeats. So like when you're factoring, you go, oh yeah, there is some repeats. That's always nice to know, so you can know some of the numbers that will appear. Okay, and we're going to, I can do restrictions now, or I can do them later, right? So it's up to you. You can do it now when it's all clean, or do it at the end. I'm going to maybe do it now. Okay, I'm going to do the restrictions now just so that I have them done. I'm going to do them on the side here. Okay. So the denominator here, I'm going to get 2x minus 3y cannot equal 0. Choose which one you want to isolate, x or y. Up to you. I'm just going to choose x. Okay, so I'm going to isolate the x all by itself, so bring the number over first. And you can say x cannot equal 3y over 2. That's 1. That's this one. Okay. Do the next one. Do you see a pattern, though, with these? Right? So once you see that, you go, you know what? It's the same answer, but negative. So if you see that and you can skip to that step, you can go, oh, I know. It's not going to equal negative 3y over 2. So you're good to do that if you can see that pattern. Right? It's the same number, it's just one's opposite. So then I got 2. This one, I reminded myself top and bottom. 4, can you restrict 4? No, no variable, right? This one, x minus 4y cannot equal 0. So bring the 4y over. X cannot equal 4y. There's another one. This one, x plus 3y cannot equal 0. So x cannot equal negative 3y. There's another one. You see, so much work. Okay, denominator for this one is 1, right? Can't restrict to 1. Go up to the top, okay, because I highlighted that, up to the top, 2x plus 3y. Do I have that one? Ooh, I have that one here. So we're good. Do I have this one? No, so then x cannot equal, x times x, 0. Do I have to say it twice? Nope, just once. There you go. So I'll be looking for those restrictions. Good, good, good. All right, then let's do our canceling. I'm going to hang on to these restrictions, and then we'll do the last part of it. So here we go. Canceling binomial with a binomial. So this whole thing with that whole thing, gone. This one, remember, multiplication makes it one big long line. So this one, X minus 4y, x minus 4. Oh, this is super satisfying. All gone? Yes. X squared, I did right there. Right? And I don't want to do x not equal to 0 2 times. I just did it once. Yeah. Okay. All right. Can I cancel anything else? Yeah. Yes, the monomials with the monomials, the binomials with the binomials. Keep hearing me say that. So here, I've got a 2x squared, and on the bottom I have a negative 4. You can put a 1 there if you want, but it's a negative 4. So the 2 and the 4 actually can be divided by 2, right? So it's a fraction. So think of it this way. So I've got the 2 here, and then there's a 4, but that's the same thing as 2 over 4. So you're dividing the top and the bottom by 2, so that makes it number 2, right? So you are allowed to cancel monomial with monomial. If there was an x there, you could look at the x, but there's nothing. There's a 4x or 2x squared. So if you want, you're pulling it aside. You're going 2x squared over negative 4, right? So the whole monomial with the whole monomial. The only thing I could cancel was the 2, so then that becomes that. So then what am I left with? X squared on the top. So
Miss Zen,
yeah.
it was in my class.
X squared on the top. Oh my gosh. I'm going to pause the video for a second.